Hey guys, in this video I'm going to explain to you the unit circle and how to use this really important tool in a trigonometry class. So here's the unit circle in all of its glory sitting in front of you. It is centered at the origin on our coordinate system, and since it's the unit circle it has a radius 1. So you can see this distance here is 1. Since it has coordinates 1, 0 right here on the edge. Okay, so this is your unit circle completely filled in with all your angle measurements in degrees, radians, and all the points on the unit circle. But before we get into how to use this tool, let me give you the basics. So in your text, you'll see that we're really focused on a point, P, with coordinates x, y, that's actually on the unit circle. So it's on the edge of the unit circle, not inside, not way outside, right? It's a point on the unit circle. And it's not just any point on the unit circle, it's the point that corresponds to an angle. And what we mean by correspond is that if we move angle theta from the positive x-axis in its standard position here, moving in the counterclockwise direction, then this point right here is the point on the unit circle that corresponds to theta. So it has to be the point on the circle that corresponds to that terminal side of your angle intersecting the circle. So when you're using the unit circle, it's all about those points, and you want to make sure you find the point that corresponds to the angle that you're working with. So here's how you use that point to help you evaluate trigonometric functions. So your point has coordinates x and y, and these are going to be any real number. Coordinates x and y, which are actual values. So then what we can do is actually evaluate all 6 of our trigonometric functions at that angle. So we have sine, cosine, and tangent. Notice that this is function notation. Instead of using f of x, I'm using things like sine of theta. Those parentheses right there are a part of the function notation. It indicates what the input is on my trigonometric function. So this is not sine times theta. No. This is sine of theta. This is function notation. So sine of theta, the way you can use your unit circle is to find the point on the unit circle that corresponds to your angle. And the sine of that angle is just going to be the y coordinate of that point. Cosine of that angle is going to be the x coordinate of the point. And tangent of that angle is going to be the ratio of these two. Now remember, we can never divide by 0, so granted, x isn't 0. In fact, if the x coordinate is 0, then tangent is undefined for that angle. Then we have 3 more trigonometric functions. We have cosecant of theta, secant of theta, and cotangent of theta. Cosecant of the angle, again, you find the point on the unit circle that corresponds to that angle. That point has an x and y coordinate. Cosecant of that angle is just 1 over the y coordinate. Again, we can't divide by 0. So if your y coordinate is 0, cosecant is just undefined right there. Similarly, secant of theta is 1 divided by the x coordinate. And cotangent of theta is the ratio of the two. So I'm going to show you some examples of where we evaluate these trigonometric functions at an angle, and we're going to use the unit circle to do that. So here is my unit circle in all of its glory. And let's say I want to use this tool to evaluate sine of 30 degrees. What's nice about this unit circle is I've given you the terminal side for each angle in degrees and radians. Again, this is the terminal side of your angle given in the standard position. So, sine of the angle 30 degrees, what I need to do is find this angle on my unit circle, and here is the terminal side for that angle. But it's not about this, it's about the point. So if I want to know sine of 30 degrees, it is just the y-coordinate of this ordered pair. So this is 1/2. Let's say I wanted to know tangent of pi over 6 radians. Now, if the angle is measured in radians, we will stop writing the word radians. There will also be no degree symbol. It will just be the value inside the function. So again, I need to find the angle on the unit circle, pi over 6, and that's the same as 30 degrees. So I found the terminal side for that angle. It's all about the coordinates of the point on the unit circle. So tangent of pi over 6 is the ratio of y-coordinate divided by x-coordinate. Now, we need to simplify this. It's bad form to write your answer as a fraction inside of a fraction. So this is just 1/2 times the reciprocal of the denominator. So 1 over root 3. And sometimes you might be asked to rationalize your denominator. So tangent at pi over 6 is just root 3 over 3. Again, it's all about the coordinates of these points. So let's say instead I wanted to find secant of 150 degrees. Secant of 150 degrees. Again, I need to find the terminal side for 150 degrees, which is right here. But it's not about the degrees, it's about the ordered pair, that point on the unit circle associated with 150 degrees. Secant is defined to be 1 over the x-coordinate of that point. So 1 over negative root 3 over 2. Again, we need to simplify this. This is bad form to leave it this way. Negative 2 over square root of 3. It's also bad form to not rationalize your denominator. So this is negative 2 root 3 over 3. Let's do one more. Let's say I want to find cosine of negative pi over 4. Negative angles move in the clockwise direction. So negative pi over 4 is right down here, moving in the clockwise direction. Here's the terminal side for that angle. Here is the ordered pair on that unit circle associated with that point. Cosine of your angle is the x-coordinate of that ordered pair. So this is just 1 over the square root of 2. In bad form, these denominators are not rationalized. I need to rationalize it. Okay, so the unit circle is a really powerful tool that you need to learn how to use. It has degrees, radians, and all the ordered pairs for these important points on the unit circle. The key to unlocking this useful tool is right here. This is what you need to commit to memory, is how you can look at the x and y coordinates to get your trig function values. This is the key to unlocking your unit circle, which is so packed full of information. And we will continue to use the unit circle this entire semester.